when we are solving systems of inequalities, we are going to put this onto a graph. I need to know how to graph an inequality. I prefer to work with my equation or inequality in slope-intercept form. So what I'm going to do in order to graph this system of inequalities is I'm going to put both of these inequalities into slope-intercept form. So I'm going to solve both inequalities for y. I'm going to divide both sides by -2. Because I am dividing by a negative number, I need to flip my sign. So my first inequality, y is greater than or equal to 1/2 x minus 5. We're going to solve this inequality as well. We're just solving for y. This one's easy. I just have to subtract 2x from both sides, and I get y is greater than -2x. So I need to graph both of these inequalities. When I graph inequalities, the biggest thing to remember is my steps for graphing an equation are the same. The difference is my line and shading. If I have a greater than or equal to sign or a less than or equal to sign, so if it has our or equal, we're going to have a solid line. So if it's either of these symbols, our line is solid. If it's a greater than sign or just a less than sign, it's going to be dashed. We have y is greater than or equal, so we know it's going to be a solid line, to 1/2 x minus 5. So I'm going to go like normal on my y-axis at -5 because that is my y-intercept. I'm going to go up 1, right 2 to continue my line. It's a solid line, so when I connect my dots and extend, it's going to be solid, so I don't have to really do anything different yet. Now I need to think about my shading. I'm going to shade above my line or I'm going to shade below my line. My preference to look at it is just to have my y on the left side, and if it's a greater than sign, so if my alligator mouth is open toward the y, that means my y is greater, which means I shade above. Another way you can decide which way to shade is you can pick a test coordinate. So after I shade, I'll show you that. So if I were to have picked a test coordinate in order to figure out my shading, you would just pick something above the line or below the line. So I'm going to pick 0, 0. That's easy. So that's something that was above my line. And the idea is if I plugged in 0, 0 to my inequality, is that it's either going to make my statement true or it's going to make my statement false. And if it makes your statement true, then you shade on that side of the line. If it makes your statement false, you shade on the other side. So 0, 0 would be 0 is greater than or equal to 1/2 times 0 minus 5. So then that would be 0 is greater than or equal to -5. So that is true. So I would shade on this upper side because we want to shade on the side that contains that coordinate. Now we need to graph the other one. So the other equation, I will use blue. The other equation is y is greater than -2x. So my y-intercept is actually 0 because we're not adding anything. So we're just adding 0. My slope is -2. So I'm going down 2, right 1. And this one is a greater than sign. So this one's actually going to be a dashed line. So points that fall on this line are not included in the solution because it is a dashed line, not a solid line. And then we can do our test point. So you could pick above or below the line, or my way is just, this is a greater than sign, so we're shading above. Once you are done shading, then you can see that the solution to this systems of inequalities is where both regions are shaded. So this combination of my purple and blue. So that's where our solutions are. Those solutions are included on the purple line, but not on our blue dash line because that one is exclusive. It doesn't count what's on here. So for example, this coordinate would not be in the system because although it's on our solid purple line, which is good, it's also on the dashed blue line, and that's not okay. It would have to be above our dashed blue line. So let's do one more example. I'm gonna graph. This is a greater than sign, so it's not inclusive, so it's gonna be a dashed line. And it's a greater than sign, so we're shading above. And then we can plot the other inequality. It's a greater than or equal to sign, so it's inclusive this time. It's a greater than sign, so I'm going to shade above. I have my solution to the system. So my solution is this double shaded region, including what falls on this solid line, but not including what falls on this dashed line. A company produces packs of pencils and pens. The company produces at least 100 packs of pens each day, but no more than 240. I'm going to write an inequality for this statement. So I'm going to use X for my number of pens, and I know that X has to be greater than or equal to 100, and it needs to be less than or equal to 240. Because we know that it has to be at least 100, but no more than 240. The company produces at least 70 packs of pencils each day, but no more than 170. Same exact thing. We're talking about pencils now. I'm going to use Y for pencils. We have to have at least 70 pencils and no more than 170 pencils. Packs. I also know that a total of less than 300 packs of pens and pencils are produced each day. So whatever my total of these packs are, they cannot add to be any more a total of less than 300 packs. So we can't even have 300. It has to be less than 300. So my maximum is 299, right? Because it's a total of less than 300. I also know that a pack of pens, we make a profit of $1.25, where a pack of pencils, we make a profit of 75 cents. So we want more pens because we would make more money. But we would still have to follow these guidelines. Then the problem asks, what is the maximum profit the company can make each day? So what I need to figure out is when I'm following these rules, what is the maximum number of pens I can have? Because the more pens I have, the more money I make. So what's the most pens I can have? How many pencils does that leave me? And then what would that profit be? So to start, let's put everything on a graph. So my inequalities, I've got 100 is less than or equal to X, which is less than or equal to 240. So X, we said, is our pens. So I've already labeled our graph. This is our pens. So I know my inequality for pens here. I'm just going to rewrite our three inequalities. So we've got, so I just rewrote my inequalities so I had them right here. My first inequality I'm going to graph is just that X is greater than or equal to 100. So I know I have a solid line at x equals 100, so it's just a vertical line, because we know that x has to fall between 100 and 240. And these are or equal to signs, so they're inclusive. That's where x is falling. So I know I can shade. Okay, so once I have shaded my area for my pens, I can think about what my inequality is for my number of pencils. So I know my number of pencils has to be between 70 and 170. So this is going to be between y equals 70. Okay, so now we've satisfied or drawn the solutions to both of these inequalities, but I know I also have to keep my total number of packs of pens and pencils beneath 300. So what I'm going to do is I'm going to solve for y just to make this a little bit easier for me to graph. That's just going to be y is less than negative x plus 300. So that's just a slope of -1. My scales are both counting by 10. So I'm just going to go down one, right one. So this line is exclusive because it is a less than sign. So I am drawing a dashed line. My y-intercept is 300 and my slope is -1. So I'm just really quickly going to draw that line. I'm going to be as precise as possible because remember that we're thinking about how important it is when we have systems to make sure your lines are accurate so that you're getting the correct answer because it depends on the graph. So this is a dashed line. Okay, so it's a dashed line, so it's not inclusive, it is exclusive, and it's a less than sign. So it's less than, so we're gonna shade below. So I darkened the portion that satisfies all three inequalities. So this little shape right in here keeps all of our inequalities true. Now I need to think back to what my question was. My question says, what's the maximum profit the company can make each day? So if we're trying to maximize profit, we want the greatest number of pens because pens sell for more. So I'm going to look at my graph. I'm going to think, okay, this is my packs of pens. So I want this maximized. I want to be as close to this corner as possible. I cannot go right on this corner because if I do that, so if I say we have 230 packs of pens and 70 packs of pencils, that's 300 total, and I have to be less than 300. What I would want to do is decrease my number of pencils by 1 because it would save me money, but I can't do that because my pencils has to be at least 70. So I'm going to choose the coordinate that puts my packs of pens at 229 because it can't be that high, and my packs of pencils at 70. I've got that smallest number of pencils I can have so I can maximize my packs of pens. So if I have 229 packs of pens and 70 pencils, and each pen pack sells for $1.25, I'm making $286.25 off of my pens. 70 times 75 cents per pencil pack. I'm going to add these two values together. And I get a maximum profit for the day of $338.75. And then I look over here and see my answer.